Imagine a time when there was nothing, not even space or time itself. A vast, timeless void, an emptiness so profound that it defies our understanding. No stars, no galaxies, no light, just an infinite expanse of nothingness. Then, about 13.8 billion years ago, there was a massive explosion, the Big Bang. This wasn't just any explosion, it was the birth of everything we know. In an instant, the universe sprang into existence, a cataclysmic event that set the stage for all that would follow. This incredible event marked the beginning of our universe. From a singular point of infinite density and temperature, the universe began to expand, creating space and time as it went. It was the dawn of everything, the genesis of all matter and energy. It was unimaginably hot and dense at first. Temperatures soared to unimaginable levels, and the universe was a seething, chaotic mass of particles and radiation. In those first few moments, the fundamental forces of nature began to take shape, setting the rules for the cosmos. But slowly, over billions of years, it expanded and cooled. As the universe grew, it began to settle down. Particles combined to form atoms, and atoms gathered to form stars and galaxies. The cosmos evolved, becoming more structured and complex with each passing eon. The Big Bang is a mind-blowing concept. It's a theory that challenges our perceptions of reality, pushing the boundaries of what we can comprehend. The idea that everything, every atom, every star, every galaxy, originated from a single infinitesimal point is both awe-inspiring and humbling. It's hard to grasp the sheer scale of this event. The Big Bang wasn't just the beginning of our universe, it was the beginning of everything. The enormity of it is almost beyond human understanding, a cosmic event of such magnitude that it defies description. But what's even more amazing is that everything we see around us today, the stars, the planets, even you and me, originated from that single point. From the tiniest particles to the largest galaxies, all matter in the universe shares a common origin. We are all made of star stuff, forged in the crucible of the Big Bang. It's a humbling thought, isn't it? To think that we are all connected, that we all come from the same cosmic event. The story of the universe is our story, a tale of creation and evolution that spans billions of years. And it all began with a single extraordinary explosion. As the universe expanded and cooled, tiny particles began to clump together. These clumps, mostly hydrogen and helium, were pulled together by gravity. Over millions of years, these clumps grew larger and denser, eventually forming massive clouds of gas and dust called nebulae. Inside these nebulae, something incredible was happening. The immense pressure and heat at the centers of these clouds caused atoms to fuse together. This process, called nuclear fusion, released enormous amounts of energy, giving birth to the first stars. These stars, much larger and hotter than our sun, became the building blocks of galaxies. About 4.6 billion years ago, in a spiral arm of the Milky Way galaxy, a giant molecular cloud began to collapse. This cloud, mostly hydrogen and helium, was probably disturbed by a nearby supernova explosion. This disturbance caused the cloud to spin and flatten into a disk. At the center of this swirling disk, gravity pulled most of the material inward, forming a protostar. This protostar continued to grow, gathering more mass and increasing in temperature and pressure. Eventually, the pressure and temperature at its core became so intense that nuclear fusion ignited. Our sun was born. Meanwhile, in the outer regions of this protoplanetary disk, smaller clumps of dust and gas were also coming together. These clumps, drawn together by gravity, collided and stuck together, gradually forming larger bodies called planetesimals. These planetesimals continued to collide and accrete material, eventually growing into the planets we know today. The early Earth was a very different place than the planet we know today. It was extremely hot, with a molten surface constantly bombarded by asteroids and comets. This constant bombardment, along with heat from radioactive decay within Earth's interior, kept the planet in a molten state for millions of years. Section 5. Cooling down and shaping up, Earth's transformation. This chapter delves into the fascinating process of how our planet evolved from a molten, chaotic mass into a more stable and life-supporting environment. Over time, as the bombardment from space lessened, Earth began to cool. The relentless impacts from asteroids and comets gradually decreased, allowing the planet to lose some of its intense heat. This cooling allowed the molten surface to solidify, forming the first crust. The once fiery and liquid surface began to harden, creating a solid foundation that would become the bedrock of our planet. Volcanic activity was rampant during this period, releasing gases from Earth's interior into the atmosphere. These eruptions were not just isolated events, but a continuous process that shaped the early landscape. These gases, including water vapor, carbon dioxide, and nitrogen, would eventually play a crucial role in shaping Earth's climate and supporting life. The atmosphere began to thicken, creating a protective layer around the planet. As Earth continued to cool, the water vapor in the atmosphere condensed, forming clouds and leading to torrential rains that lasted for millions of years. These rains were not just brief showers, but intense downpours that significantly altered the planet's surface. These rains filled the low-lying areas, creating the first oceans. The formation of these vast bodies of water was a monumental step in Earth's transformation, providing a habitat for the first forms of life and setting the stage for the complex ecosystems we see today. The developing atmosphere, rich with volcanic gases, began to stabilize, creating conditions that would eventually support more complex life forms. This period marked the beginning of a long journey towards the diverse and vibrant planet we inhabit now. In these primordial oceans, the first microbial life began to emerge. These simple organisms played a crucial role in further transforming the atmosphere by producing oxygen through photosynthesis. Over millions of years, these early life forms evolved, leading to more complex organisms. This gradual evolution was driven by the changing environment and the availability of new habitats created by the cooling and shaping of Earth. Today, we see the results of this incredible transformation in the diverse ecosystems that cover our planet. From the deepest oceans to the highest mountains, Earth's journey from a molten mass to a life-supporting world is a testament to the power of natural processes. As we look at Earth from space, with its blue oceans and green continents, we are reminded of the dynamic history that has shaped our planet. This transformation is ongoing, with Earth continuing to evolve and change, driven by the same forces that have been at work for billions of years. Understanding Earth's past transformations helps us predict and prepare for future changes. As we face new challenges like climate change, this knowledge is crucial for ensuring a sustainable future for all life on our planet. Scientists and researchers continue to study Earth's history to unlock the secrets of its transformation. Their work not only helps us understand our past, but also guides us in making informed decisions for the future. In the vast expanse of the universe, Earth stands out as a unique and precious home. Its transformation from a molten mass to a thriving world is a story of resilience and adaptation, reminding us of the delicate balance that sustains life. Section 6. The rise of life, a biological miracle. Around 3.8 billion years ago, our planet was a vastly different place. The Earth was young, and its surface was a chaotic landscape of molten rock and volcanic activity. Amidst this turmoil, the first oceans began to form, providing a unique environment for the next great leap in Earth's history. In the primordial soup of Earth's early oceans, something extraordinary happened. Life emerged. This was not a sudden event, but a gradual process that unfolded over millions of years. The exact details of how life arose from non-living matter remain a mystery, shrouded in the mists of deep time. Scientists have long pondered this enigma, piecing together clues from geology, chemistry, and biology. But scientists believe that simple organic molecules, the building blocks of life, began to form in these early oceans. These molecules, perhaps delivered to Earth by comets or asteroids, played a crucial role. These celestial bodies, rich in organic compounds, may have seeded our planet with the essential ingredients for life. These simple molecules, through a process called chemical evolution, began to interact and combine in increasingly complex ways. This process was driven by the energy from the sun, volcanic activity, and lightning strikes, which provided the necessary conditions for chemical reactions. Eventually, these interactions gave rise to more complex structures, such as amino acids and nucleotides, the precursors to proteins and nucleic acids. These complex molecules began to assemble into the building blocks of life as we know it: proteins, nucleic acids, and lipids. These building blocks, over millions of years, underwent further evolution, leading to the formation of more sophisticated molecules and structures. Proteins, with their diverse functions, nucleic acids, which store and transmit genetic information, and lipids, which form cell membranes, were all crucial in this process. These building blocks eventually assembled into self-replicating structures, capable of copying themselves and passing on their genetic information. This was a critical step in the evolution of life, as it allowed for the continuity and diversification of living organisms. These self-replicating structures were the precursors to the first cells, the simplest forms of life. From these humble beginnings, life on Earth began its incredible journey, evolving into the vast diversity of organisms we see today. This remarkable process, from simple molecules to complex life forms, truly is a biological miracle. Section 7. A symphony of science, physics, chemistry, and biology in harmony. The formation of Earth and the emergence of life are testaments to the interconnectedness of physics, chemistry, and biology. The laws of physics, such as gravity and nuclear fusion, govern the formation of stars and planets. Chemical reactions, driven by energy from the Sun and Earth's interior, shape the planet's atmosphere, oceans, and continents. And within this dynamic environment, the intricate dance of biology led to the evolution of life, from the simplest single-celled organisms to the complex diversity we see today. Section 8. Our place in the cosmos, reflecting on Earth's journey. As we've journeyed through time, from the Big Bang to the emergence of life on Earth, we've witnessed the awe-inspiring power of the universe and the intricate chain of events that led to our existence. Earth is a precious oasis in the vastness of space, a testament to the delicate balance of forces that make life possible. Section 9. Join the exploration, subscribe for more cosmic adventures. Thank you for joining me on this incredible journey through time and space. If you're as fascinated by the universe as I am, don't forget to subscribe to the channel for more cosmic adventures. Together, let's explore the wonders of the cosmos and unravel the mysteries of our universe.